Hello, am I audible?
Yes, sir. They said, Sayyad, you are audible clearly.
Okay, and video is working fine?
Yeah,
Okay,
it
thank
is
you.
working.
Is the screen visible?
Yes, sir. Screen is visible.
Okay. And
Engineering physics. Yeah.
हाँ, ठीक है. Let me know when the meeting starts.
Good afternoon, everyone. This is Saurabh here from Bennett University, Greater Noida, the Times Group. So today we have a very wonderful session with us on engineering physics, where we understand how we can bridge the gap between innovation and implementation. So without wasting more time, I would like to introduce Dr. Ayan Khan, the man of the hour. So kindly welcome him with a big round of applause and we'll start the sessions. Over to you, sir.
Okay, thank you, Saurav. So it's great to be here and discuss about engineering physics. Already I can see I received a question, and which is a very common question and which I am going to address through this discussion. And please feel free to interrupt whenever you feel. And I request Saurav also, please feel free whichever point you will like me to elaborate more.
Sure, sir. Sure.
Okay, so please stop me. Let's try to keep it more interactive so that we can understand each other better. Is that fine for all of you? Okay, so let's start. The engineering physics, this term itself is not very well known in to the mass, but it is a very well-known name for the actual keen students who want to bridge between, as I have said, between engineering and theoretical application. Basically, engineering physics, this program started in 1940s at that after Second World War, when in US people understood there is a gap between the academia and there is a gap with the industry application. So to address this gap, this course engineering physics was launched. In India, this course was first launched in 1981-82 in IIT Bombay. And subsequently, later in early 1990s, IIT Delhi launched it. But we will see in next few slides, in the last 4, 5, 6 years, this has become a very attractive field for study for undergraduate students. And one after another IITs are opening it up. And the advantage for Bennett is that this is the only private university in entire India which offers this program for last 8 years. So we have a considerable experience of students who have passed out, did remarkably well, and we will try to bridge and try to shed light on all these aspects in next half an hour, 45 minutes. Okay, so let's start. So let's start from a discussion. I don't know how many of you are aware of it or not. So the last year, 2024 Nobel Prize in Physics, where it went. So the Nobel Prize in Physics in 2024 went to John Hopfield and Geoffrey Hinton. However, for what they won the Nobel Prize in Physics? That is a very interesting, because at this moment, all of you are very much familiar with advent of artificial intelligence. You are doing, all of you definitely have already tried ChatGPT, Grok, and some other generative AI platforms and tried to find out some answers. But how they work? These two gentlemen actually tried to address this aspect, that how they work. And you see the Nobel citation says, for foundational discoveries and inventions that enable machine learning with artificial neural networks. At this tender age, young age, just after 12, you might not be able to understand these words very clearly. I will just try to give a glimpse a little bit. I would like to just talk to give you the actual connection to it. So you have studied in thermodynamics. You have already studied thermodynamics. The story actually begins from there. in your 11-12 textbook, you have studied Maxwell's thermodynamical equation. And then the students who have a more keen interest may have studied a little bit more, may have studied something called Maxwell's engine. So these thermodynamical phenomena with some advanced level applications, say there are something called Ising model and so on. So from there actually goes to the root of neural networks. Neural networks, the name came from to understand in the research of neurons of the brain, and then how to implement it in computer network. And this theory is purely a theory derived from physics, the field of physics which is called statistical mechanics and which complex systems. So in BTech EP program also we have these courses. So you can understand that whatever is most sought after in these days and which is people expect is to change our understanding in the coming years, that actually derive from some fundamental laws of physics. Now, if we move further, we'll see the next year, the 2024 Chemistry Nobel Prize. Now, 2024 Chemistry Nobel Prize, the citation says, for computational protein design. Now, this is where actually the title of this seminar comes into play. What the title was, this is from innovation to implementation. This is the innovation part and this is the implementation part. So this is also AI based, theoretical protein design. So these works are also AI based works, and in protein design, these gentlemen used the AI algorithms for protein design. So this is how this actually bridges your innovation with its implementation. Now, today actually I started the discussion mostly on AI because this is the topic which all of you are too much excited about, and many of you are trying different things with Grok or ChatGPT or Gemini or whatever generative AI platforms. Now comes to the question. These are sounds very simple while you listen. Now let's come to the question. What is actual status of these implementations? So what happened last month, I was fortunate to be in International Center for Theoretical Physics at ICTP in Italy, where several Nobel laureates actually gathered together and talked about quantum technology. So that is another buzzword you might have heard about, but this buzzword is relatively quieter compared to the buzzword like AI. So that meeting where I was fortunate to attend, this was on the 100 years of quantum mechanics. So 100 years of quantum mechanics, what do we mean? That is actually in 1925, one of the most fundamental ideas, important fundamental ideas came into effect. That is called the Schrodinger equation and Heisenberg uncertainty principle. And to celebrate that, this year UNESCO has dedicated this year as International Year of Quantum Science and Technology. Now comes, this story now becomes a bit intriguing. So this meeting was dedicated to discuss the current status of quantum technology. Quantum technology, you may have already heard about something called quantum computer. So quantum computer are still in the research mode, and there are some quantum computers, IBM Q, such as IBM Q. Then there is Google Quantum Supremacy. There are some quantum computers already built and people are trying to use it. So the most interesting part was there. We were fortunate to hear from Matthias Troyer, who is actually corporate vice president of quantum at Microsoft. And he actually showed us what is the status of quantum technology. So what happens at this moment, if you have, you can see two pictures. These are the pictures from his Matthias Troyer's presentation, which I had taken while listening the talk. These two pictures are quite intriguing. What happens if you want to do small calculations? Your classical computers are very good. But as system size increases means there are more complicated systems you have to analyze. The efficiency of quantum computer is higher than classical computer. Now in classical computer, this type of most complicated models are usually calculated something called technique called HPC, or which is called high performance computing. Now in high performance computing, if we add the AI and the quantum advantage, then the current computation is most suitable. And what kind of computation this kind of hybrid system does? They actually works on the field of drug discovery, protein folding, and that is why you see here in the chemistry, they got the Nobel Prize for the computational protein design. So drug discovery, protein folding, financial market analysis, weather prediction, these are very complicated models. And to get into these models, to understand these models, what you actually need, you need a basic knowledge of AI, you need a basic knowledge of quantum computation, you need basic knowledge of high performance computing. There is something more to it. There is material science. There is another very important field, material science, to design new materials for energy harvesting, natural energy harvesting, say solar cells, to make solar cells which can capture more solar energy so that we can have batteries, to construct electronic vehicles. For constructing the batteries and supercapacitors, you need to make new materials. And there also the combination of high performance computing, artificial intelligence, and quantum computation, that plays a role. Now you understand that actually to work in a high-end direction, cutting-edge research topics, and to work in the top-notch companies, your classical computational knowledge is not sufficient. Your knowledge of knowing only bit of quantum mechanics, what in a BSc course people studies, that's also not sufficient. If you join an AI program learning some AI tools, that's also not sufficient. Here, let me give the answer which one of you already asked. What is the basic difference with BTech EP and BSc Honors Physics? So this is the difference. BSc Honors Physics guides you towards a regular BSc program. After that, you do MSc, and then you can choose whatever direction of your life you want to choose. But this 4-year program actually enables you with the fundamentals of high performance computing, artificial intelligence, and quantum technology. How they enhance this? So I will come to that with practical examples. So in some way, I always say this is a really multidisciplinary approach. And you are all familiar with the word jack of all trades, master of none. But that is not the entire saying. The entire proverb says jack of all trades, master of none, but oftentimes better than master of one. So BTech Engineering Physics actually gives you the ammunition to grow in future in different direction. How it gives you that ammunition? Let's step by step, let us discuss. So what is engineering physics? A little bit I have already discussed. Now you can ask who is the best suited to study these courses. Of course, the fundamental requirement for this course is a good grip on mathematics. If you are good in mathematics, then you can do wonders. And then comes what is the prospect. So these are the points I will touch upon. Now there is another question will come, that why at Bennett University? So for that, I will request you to please look into our Bennett website and verify by yourself. We have a fantastic team of faculties. Don't get my word, but check there from where all the faculties have studied, what is their background, how many years of international experience they have, what are the research fields they work. Then rigorous training through international standard curriculum. Why do we say that? I'm coming to this. We have extensive international connections because all our colleagues have spent years, more than, on an average, more than 5 years in different labs, cutting edge labs across the world. And also we have fantastic laboratory facility, and we in general keep small batch size because these high-end experimental facilities we cannot offer to hundreds of students. This is not possible. So we keep our batch size small so that actual experience, doing by hand experience, experiential learning is properly fulfilled. Any question till now? Okay, so let's move ahead. So now if you study BTech EP, what are the fields you can go? As I was telling, there is possibility to go in different directions, like electrical engineering. Why? How electrical engineering? Because we have some rigorous courses on semiconductor physics, nanotechnology. Now these courses enables the student to join electrical engineering and chip building. So you know there is, from Government of India, there is a lot of emphasis is given on semiconductor industry in the current days. And to suit yourself, you need fundamental knowledge about condensed matter physics, semiconductor physics, material science, nanotechnology. These are our core courses in the BTech EP program. Then biology. So whenever you have to do the biology, the computational biology, what you need to know. We have courses like biophysics, and we have courses where we discuss the molecular dynamics, molecular modeling, which actually leads to the protein folding kind of problems. Then operations, finance, it is a very interesting aspect. I don't know whether you are aware of it or not. From IITs, the most of the BTech EP students actually join very high-end companies in the financial sector. Why? The reason being, they are trained so well in mathematics and in physics that becomes instrumental to analyze the financial sector, the current bottlenecks of the financial sector. Then there is telecommunications, and we have courses on photonic science and technology. This photonic science and technology can allow you to go to the optical fiber communication system. And there are very interesting stories from our passed out students who are doing very well by choosing this field, telecommunication, laser. And at the end, of course, you can join IT. IT is usually for BTech engineering physics student, IT is the least preferred option, because in general in IT, the common entry level jobs, average salary starts from 5 lakhs, 6 lakhs per annum. But for engineering physics, they prefer the financial sector, where the entry level is much beyond 10 lakhs per annum. So it gives a much better entry level option through engineering physics. Well, so these are the 6 specializations which we offer in BTech EP program: nanoscience and technology, quantum science and technology, complex systems, biophysics, renewable energy, and astronomy and astrophysics. So this is why, again, I try to emphasize the point which I had made at the very first slide, from innovation to implementation. So you actually get trained the fundamental level, the innovation level for these cutting edge technologies, and then you are ready to join the industry to make the change. Well, so as I was telling you, we have fantastic group of faculties. Here, let me give you a brief description of that. So I am Dr. Ayan Khan. I did my PhD from University of Camerino in Italy. My MSc is from IIT Guwahati. Then I had 4 years postdoctoral experience in Pusan National University in South Korea and Bilkent University in Turkey. We have colleague Dr. Poulomi Sadhu Khan, who did post PhD in IOP Bhubaneswar, another one of the premier research lab in India, and spent several years in Amsterdam and Göttingen. We have Professor Sarup Panda, who did PhD from Cultivation of Science, ISCS Kolkata, India's oldest research institute, and then spent several years in École Polytechnique in France and Uppsala University, Sweden. We have Dr. Soumendu Roy, who did PhD from IIT Bombay, then spent several years at University of Tel Aviv and IIT Kharagpur. We have Dr. Shubhadeep Mondal, again from Cultivation of Science, who is from the background of particle physics, and he spent several years in HRI and University of Helsinki. We have Umesh Kanta Singh, who did PhD from JNU and spent several years in Max Planck for mathematics in science in Germany and Louisiana State University. His background is from complex systems and he offers courses related to physics and machine learning. Also, Dr. Shubhadeep Mandal works the machine learning in particle physics, application of machine learning in CERN data. CERN, I hope you know, the energy accelerator in Geneva. Then we have Dr. Sudeep Chatterjee, who spent several years in IISc Bangalore and IIT Kanpur. He is experts on photonics technology. We have Dr. Sachin Gupta, who did PhD from IIT Bombay and spent several years in Japan and in United Kingdom. We have Dr. Arindam Lala, who specializes in gravitational physics, who did PhD from SNB-CBS Kolkata and spent many years in Chile in the observatory, Fondacity Observatory in Chile. His main research areas are gravitational physics, cosmology related topics. Then we have Dr. Ketan Rathod, who did PhD from IISc Bangalore and spent several years in Israel as well as Singapore. So you can see we have a wide range of international connection, direct connection through faculties. This actually enables our students to directly go abroad without even any MOU between the universities, from our own connection, from our own recommendations. Now, as I have said in the very beginning, our curriculum is very well connected with the international standard, and to establish that, actually we have a fantastic group of people who suggest us in driving and modeling the curriculum. We have Professor Pankaj Srivastava from Department of Physics in IIT Delhi, Mr. Rana Pratap Sarkar, who heads quantum computing in Ericsson, Professor Alok Shukla, who happened to be our founding HOD of Bennett University. He is now in IIT Bombay. And then we have Professor Biplab Sanyal from Uppsala University, Material Science Division, Head of Material Science Division. Then we have Dr. Nikita Daga, who is Director of Laser Quant, who is driving a startup on photonics-based technology. And then we have Dr. Chiranjeev Shur, who is Head of Engineering Scientific Software in Shell. So he actually looks at high-performance computing side. So you can see, as I have started from the beginning, I'm talking about at this age, we are all excited about AI, but what actually, where the future lies is AI, quantum technology, and high-performance computing. And our BOS members, all expert from all these fields, and helps us drive and design the curriculum in an appropriate manner so that the student can get an edge. So this is a brief about the engineering physics. So where engineering physics runs in the US, there are top places: Stanford, Harvard, Princeton, UC Berkeley, Cornell, Toronto, and so on. And it actually, as I continuously trying to emphasize, it talks about theoretical science and practical engineering knowledge. That differentiates it again from the regular BSc Honors Physics program. In the BTech EP program, you will be studying courses on electronics. You will be having a first year fundamental level Python course. Then you will be taking data structure course, computer network course. Then you can take signals and system in electronics, very important topic. And then we have a more high performance computing to lead to high performance computing. We have a core course on computational physics. Then there are elective courses on machine learning, elective courses on quantum computation. So that then we have elective courses on renewable energy. We have elective courses on photonic science. So these gives the practical engineering age for an BTech engineering physics student. So here, this is actually, all of you maybe already appeared for advanced, JEE advanced. And here actually this shows the total, how in the recent years, how there is a certain excitement has increased to the BTech engineering physics. This table is collected from the JOSA government website, and how every year the seats are increasing. From last year to this year, there is 80 seats increased in BTech engineering physics, and there are several new IITs have started offering it. So as I was telling you, this actually gives you to the age in the nanotechnology, quantum technology, automotive engineering, energy technologies, financial sector, edutech, all these fields. It gives you an age to enter. It is not if you do a certain discipline, regular engineering discipline, it leads you a certain direction. But the engineering physics has the ability and the multidisciplinary training that allows you to move at different directions after 4 years based on your interest and at that point market demand. AI is market demand today. After 4 years, you don't know what will be the market demand. So that is the, you can say, that is the most important part of engineering physics, which actually makes you, gives you a diverse, rigorous training based on the market demand, and based on your interest, you can then follow the path. Well, let's just talk a little bit briefly about the pedagogy. So we have a lot of courses on maths, and we have courses on electronics. So you can see there is 67% courses on science, 23% courses on engineering, and 10% courses are on social science. And you can see there are 56% lecture-based courses, 36% practical-based courses, and 8% tutorials. And this is what actually some old data taken from IIT Madras, they actually keep the data very well. And here you can see the median salaries for some engineering branches, say computer science, electrical, mechanical, and engineering physics. And you can see the engineering physics median salary is very high because the entry level itself in engineering physics is high. Here, there is a very interesting point. We can break this data in a different way. What happens? You all know that from every engineering campus, some computer science students gets a very high salary job in from IITs. But the average salary, if you see, it only comes 25 lakhs per annum. Why it is so? Because there are some students who get a very high salary job, but there are most, they go into a very entry-level jobs like 5 lakhs, 6 lakhs per annum. So to capture this data, here actually we have calculated the maximum to minimum CTC ratio. And if you look into that maximum to minimum CTC ratio, you will see engineering physics is relatively low here. Low means what? Low means here the entry-level salaries are itself high. Engineering physics program offered by all IITs are also by limited number of students. And these limited number of students, when they go to the job market, on an average, they get a pretty decent entry-level package. And that is why maximum to minimum ratio, you can see is relatively low when we compare to electrical engineering, mechanical engineering branches. However, please note these two slides, these data are completely prepared from the IIT Madras placement data. What about here? We are already 4 batches passed out, 5th batch is going to pass out. What they are doing. So let's come to those points. So this is our 27-21 batch, where students mostly showed interest in higher studies, and most of them went to top places in Europe. And University of Cologne, University of Heidelberg. Then the one student went to US, Montclair State University to do masters in data science. Some students joined at that time in Byju's with a pretty high salary package, and so on. In 1822, students again chose from here mostly higher education. They went to Cardiff University with scholarship. People did summer internship in Indian Institute of Astrophysics. And then IIT Tirupati, Aizar Mohali. One student from that batch went for last semester 6-month project with full scholarship to Johannes Gutenberg University, Mainz, with full scholarship. And after that, he did his master's there with full scholarship. Some went to Chalmers University in Sweden, some to Aalto in Finland. In 1923 batch, one of our students went to Padova with full scholarship, with whom this time I have met when I went to Italy last month. She came down to Trieste and to meet me in Padova. She is in Padova, is close to Trieste, so she came down. One of the students went to Durham University just after BTech direct PhD program, which is very tough to get, and with full scholarship. Then others, one student went to cleared MTech and went to IIT Roorkee to do MTech in photonic science and technology. Some went to Helsinki, some went to Netherlands in environmental science. One of our student, Uzma, she is very much passionate about environment, so she joined in Wageningen University in Netherlands, which is world rank 2 in environmental science research. In 2024 batch, the topper, he went to ANSYS, got a very good package in ANSYS softwares because of the training he had in his 6-month project in the industry. And he got a very high package. Then others have joined in National Physical Laboratories. Some joined in Aizar Bhopal, some joined in Physical Research Laboratory, and so on. These are typical job profiles taken from IIT Madras data, which talks about if you want to know. So there are diverse job profiles. You can see people takes from engineering physics background. Now, at the very beginning, we have said that we have fantastic labs, and the labs are even, we can proudly say, even better than many new IIT labs. Of course, old IITs has a much better lab, but being a new university, we have a fantastic experimental facility. So these are very high-end experimental facilities which students get opportunity if they are doing project in material science or nanotechnology. Then this is a very high-end, this is called the sputtering unit for fabrication of thin films. We have a computational cluster, which is for high-end computational research, high-performance high performance computing. Then we have a quantum information processing lab, where we do research on envy-centered diamond defects based on envy-centered diamonds, and using them, how we can do quantum information processing. We have our own XRD system, which is also a very high-end equipment, and which again student gets opportunity to handle if they do the research on material science. These are some recent activities of the department. Very recently, we have a professor from Japan, Tokyo University of Agriculture and Technology. These are very recent things, because for last 9 years, we are doing many conferences, seminars, and we cannot give all. So this just, you can see, this is just the last month, we had a speaker, Masahisa Watanabe from Tokyo University of Agriculture and Technology, where he talked about nonlinear dynamics and how nonlinear dynamics is being used in tractor designing. In field, tractor toppling is a very troublesome issue in agriculture, and this tractor toppling causes human loss as well. Now, how to design the tractors so it doesn't topple? So there he is using nonlinear dynamics theories on that direction. Then we have a Marie Curie fellow, Arpadev Pal, visiting us, and he talked about the spins, lattice, and dipoles on helical magnets, so based on material science. Then we had student conference, and in student-led conference. This is not a conference organized by the department. Department just supported. Our undergrad student, in collaboration with students from Shiv Nadar University, Gautam Buddha University, and we have an Optica student chapter. So all of them together came together and organized a 3-day student conference, which is called Ampere 25. Then we frequently invite our ex-student alumni to come to the campus, and very recently we had 2 alumni, Nikhil, who recently got a full fellowship PhD program in University of Grenoble. Just a week back, he called me up and confirmed me. He came to the campus, talked with the current students, and shared his wisdom, his experience abroad. Then we have Akash Warke. He also came a couple of months back. He got a very, very prestigious fellowship called Clarendon Scholarship at University of Oxford. With that scholarship, he will now be studying PhD there. So Clarendon Scholarship is one of the most prestigious and scholarship for PhD program in the University of Oxford. Then we also go for visits. So last semester we went to ARIS, or Aryabhatta Research Institute of Observational Science. So all students went there, and the institute was kind enough to show us the stars, night sky, the stars, nebulas, the Saturn rings, and it was exciting experience for all the students. We had a 3-day exciting trip to Nainital through ARIS. These are a small bunch of our international achievers, because we cannot give all students name, that becomes a too big list. Here just I like to point out this girl Uzma. She decided to carry her career in environmental science. She is very much passionate, and joined in Netherlands in the university, Wageningen University, which is world rank 2 in environmental science. This guy Chaitanya, the first batch, he wanted to pursue his career in data science. So he went to do masters in data science. Akash Warki's case, I have already told you, he is now doing research basically into the domain of quantum technology. Aditi Chauhan doing masters at Cardiff University on astrophysics. Katha Senapati, with whom I met last month, who is doing with full scholarship research in observational astronomy. Nikhil Saraswat recently got PhD position in Grenoble on material science research, and so on. So we have fantastic group of students. They are doing exceedingly well. We also have two very successful startups, one by Pradyuman Mane and one by Raunak Gulati. Pradyuman Mane's objective is to connect the MSMEs with the academic institutions. That is what his startup Physics Mind Boggler does. And Raunak Gulati had a startup, Horse's Mouth, which actually connects the students, aspiring students who want to go abroad. This platform connects the students with the students who are staying in those respective universities, Indian students. This Horse's Mouth connects them so that practical information, a priori going to the place the student sitting here can get. We have fantastic faculty achievements, 15 external funded ongoing projects or completed projects of nearly 2.2 crore. We have cumulative 50 years of international research experience, and as I have said, all the faculties are from premier institutes like IITs and IIScs. Our colleague Swarup Panda is winner of Young Achiever Award from Department of Atomic Energy, Government of India. We have Dr. Sachin Gupta, who is winner of Ramanujan Fellowship from DST. These are some of our research description, which at this point, I know you will not understand much, but the point is our student also contribute in this research activity. And as I have said, this girl, Katha, I have written last year a paper which published in a reputed international journal with Katha. Nikhil had paper with Dr. Swarup Panda. Jammu Tarun in undergraduate project, based on his undergraduate project, has a paper with me. Adit Sen has undergraduate paper. All are in top tier international journals papers. And Adit Sen had it with Dr. Swarup Panda. Akash Warki had with our former HOD, Professor Tyagarajan. He had paper with Professor Tyagarajan based on his undergraduate project. Valay Jain had paper with the professor from IISER Kolkata, Professor Prashanta Panigrahi, when he went for a summer internship. So students are continuously involved in research, and that is somewhat reflected in this publication data as well. Excuse me. So these are some collaborations, Indian and international collaborations, which our faculties carries. So with this, I like to conclude my talk. I like to thank you all. And if you have any question, please feel free to ask me. Thank you. Saurabh.
Thank you. Thank you so much, sir, for our wonderful insights on engineering physics. Now I would request all the students, those who are there in this session, if there is any doubt, you may ask. Because we'll be winding up this session in another 2 to 3 minutes only. You can also type your questions or you can raise your hand if there is any doubt.
I think there is one question is there, I think. That you have already answered, sir. So yeah, astrophysics. Okay, I think Aditya got your answer. Many students have joined in the astrophysics. Some joined in the observational astronomy. Some joined in theoretical astrophysics. And we have elective courses on astronomy, on cosmology, gravitational physics, particle physics. These are elective courses.
Okay, fine, sir. Thank you so much for this wonderful timeout for us. And once again, thank you so much to all the students. And if you are willing for more further information regarding the fee structure or the eligibility criteria, you can visit our website www.bennett.edu.in so that you can get more info about the program placement package and all, though it is already been shared, but you can again get connected over our website.
I would like to add here that
yes, sir.
From this year, there is another advantage. The BTech Engineering Physics, with BTech Engineering Physics program, student can do a minor in computer science or a minor in electronics. So
that's wonderful, sir.
This is an added new curriculum, NEP enabled curriculum that allows a student to complete BTech Engineering Physics with minor in computer science or minor in electronics.
Oh, that's wonderful, sir. That will surely it will benefit the students. That's all for the day. Thank you so much for attending. I request all the students to leave the session. I answer, you can also end the session.
Okay, Saurabh, is there any student left in?
Yes, sir. Students are simultaneously lefting. You can also left the session, sir.
Okay. Thank you very much. Thank you all.